Um, Hello chat. Well, Ebo Nation. Welcome to the first ever live shader coding session. So today, as you can probably surmise, we will be doing this here pride flag. Um, there's lots to say about a flag like this politically, which will not be covered in this video. There's also a lot said to be. There's a lot said vexillologically. Um, some would probably argue it's pretty ugly, but from a shader standpoint, it's a very interesting flag and a great exercise. So I thought that we'd start here with a fairly simple shader at the start of a new year, 2026. How exciting. So, yeah, I was looking around for like an image of this flag. It's usually you can look up like Union Jack construction sheet, and you'll get something like this where it'll give you the dimensions and easy to work with. I was not able to find that for this here pride flag, so we're gonna have to get a little dirty then, because this is an SVG though, which makes things super easy. So we can just look at the source code and boom, that's how you do it. So if this video was live SVG coding, we'd be done. But we're doing shader coding. So I had never even looked at SVG code until like preparing for this video, which was not very in depth, but kind of just stared at it for a bit. Oh, actually, no, what I actually did was SVG live editor, put it in here. Oh, yeah, put it in, oh my God, there, okay. So you can highlight over the little tags or whatever, and it'll show you the region that it's in. And then you can kind of, this like seemingly random string of characters kind of starts to make more sense, where you have this path, which is the whole thing, then one less stripe, then one less stripe, blah, 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 blah. So here, this path must be this red stripe. So, and if you look at this, that's 1200, these are all 1200. This probably means the width, and then this must be the height. And this maximum one that covers all of it has the same dimensions as this view box, so that makes sense. So if we do like 600, yeah, now that's in half. And so we can use this same principle to create this your little standard pride flag. So let's do that. So this is shader toy. It's probably, I mean, if you know what shaders are, you probably know what shader toy is. But essentially, it's just a little environment for you to write shader programs. So here is probably, this is where I always start. Just like this, you take in, this is a function that runs for every single pixel of your texture or whatever. The shader will run this function. But then if you're like, if all you're saying is give me 1 red, 0 blue, or 0 green, 0 blue, 1 alpha, everything's gonna be red, of course. But then the question comes then, how do you like actually do something with this? Because you need, if you have one program running for every pixel, then there's not much you can do. Well, you get this frag chord in, which tells you where along this you actually are. So here's 0, 0, here's 1, 1, here's 1, 0, here's 0, 1. So with that, you can, I mean, the world's your oyster at that point. So this will be in the range from 0 to 1 squared. So each x is 0 to 1 and y is 0 to 1. With that, you can say, give me my r, my red, green, blue. I want r to be the x value of uv, and I want the g to be the y value. And that's how you get this. And then if you want the cooler version, you have this. But yeah. And then you can save time by doing that. But okay, I'm distracted. We need to do this. So I'll start with just grabbing these colors. It's a bit smushed for now, but let's do Vec3. Just call it red. So the colors are in hex, and you can just do hex like this. So 60, 23, 80, and then so that's in hex. So then if you just divide by FF, const int. Okay, that works. 3, orange. I'll probably jump forward until I'm done filling this out. Let's do orange. Actually, let's make sure this red works. So, red. That's purple. Oh, okay, I'm looking at it backwards. Yeah. But that works. The hex works. Purple. Okay, Vec3 blue. Very little blue. And so those are all our colors. Now we need to actually render the stripes. So we have a height of 762, and these change, or the initial one is 127. So 127, 762. What is this fraction? 1/6. Cool. So that means that, and yeah, there's 6 of them. They're equally spaced. I should have pieced that together, but yeah, they're each 1/6, and we already know that that our x and our y range from 0 to 1. So then this will step by 1/6. So this is 0, or this is 0, this is 1/6, this is 2/6, 3/6, blah, 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 all the way up. So what you can do is, say we wanted to go from purple to blue. We can do, we'll just start with the Vec3 color and initialize it to white, just so we see it. Okay, so actually we want this to be purple. Start at purple, then the color will be step. We'll want to step from at 1/6. Okay, yeah, we want to step, so we can actually do mix, where we'll mix between purple and blue, and at the step of the UV's y coordinates at 1/6, and that should create the stripe. I got it backwards because we're at purple, then lights. 0, 7 return 0. For all these, for all values, less than 1, 6, 1, 6, 7, 1, 1, so why, even though we missed it, why increase numbers? So why is that? I think that early. Why? That is that from something, something like what? It's black. Okay, oh my god, wait. Did I get my parameter order wrong? Edge X. Okay, this is just backwards. So the edge is 1/6 and the X is our uv.y. There we go. Okay. Okay. Thank God. Purple, so I'm gonna go from purple to blue. And now we kind of just have to chain these together. So we want to go from purple to blue, and then from blue to green, and from green to yellow, and from yellow to orange, and from orange to red. So, like, I think if I just chain one more time. So instead of blue, we want the blue to be, this is purple or blue. This is blue or green. Let's just, I don't really know what's the best. Just call blue green. And we'll do the same thing where we mix from blue to green. And we step. Although this time it'll be at 2/6 uv.y. Compile. And then instead of blue, we have blue green, and that should, yeah, so that's added the green stripe. Now, if we go from green to what, yellow? Green, yellow is mix from green to yellow, step 3/6, and uv.y compiles. So now instead of green, we want green, yellow. And now yellow to orange. We have orange, mix yellow, orange, step 4/6. Compile. Instead of yellow, we have yellow, orange. And finally, we do orange or red. Pick 3, orange, red. Mix, red, step at 5/6 uv.y. Orange, orange, red, and boom. Okay, so that's gay done. We did that. Now we need to get this like chevron type of deal with trans and black and brown, because why not? Just, you know, just in case anybody felt left out. So I'm not prepared to do this. I had like mentally wrote this in my head, but now I'm on my own. So we need to figure out how these, what I'll just call chevrons, work. it would really help if I understood SVG. And this is the type of thing where you can kind of just throw this into an LLM and it'll tell you exactly what you want to know about this. And that's like, that's a good thing. That's cool that we like have that technology. But obviously, live shader coding, the point of this educational program is to educate both myself and the viewer. So I'm not doing that. So that I'm gonna figure this out. So this is our final color. If we then, what do we say it was 315 over 762. Let's say float H for now, or what is this SVG fucking saying? H, yeah. H is 315 over 762. That is precisely where actually, I don't really know, honestly. Color, we're gonna go from color to, we'll just do black. We're gonna go from color to black, and we will step at H, given uv.x this time. So we'll have gay, and then as uv.x, is this, okay, I'm backwards. But if we have 0x going to 1, as we pass, say H is here, as we pass to H, we'll go from color, which is gay, to black. So if I compile, we should see gay on the left and black on H. Yes. Okay. So that's expected. The issue I see, what I'm kind of confused about is this, like, that's not where, like, this should be. This is over one half, but the H is not. So that's something I need to get, like, I really don't understand. This is pretty annoying. TBH. 315 over 762. Like, what? And what is this L? Like, what is all of this? I don't understand. 315, what if I set U 762? Yeah, we're not all the way. So also this is not even either, so if we very much don't, is there no progress private flag construction sheet? See, I've been down this road before and not a lot of helpful information. That's it. Progress.gay. You can have .gay. That's pretty awesome. Okay, that makes my life so much easier now. This is not precisely what we're looking for. In fact, we're missing the intersex components to our flag. which I don't want to miss because like that's more fun shadering to do. But I think for the sake of this video, we'll say that these dimensions are accurate. Cause I don't wanna fucking, I just swore. I don't wanna deal with this SVG like at all anymore. Honestly, spec doesn't, yeah. We're going off vibes officially. Screw this SVG. We're going off vibes and visuals. Okay. What would be helpful is if this is 0. Like if our origin is, right now our origin is going from bottom left 0, 0 to top right 0, 1. It would be much easier to do things if we set the origin to say this is y equals 0, and then this will be positive half, negative a half. That is useful because any routines we write to determine the color of a pixel based off its UV coordinate, which is like all that shaders are, can be simplified because you have this vertical symmetry. So if you just take the absolute value, then these will be the same just inherently. And you say, oh, what about the gay? Don't fret if you're into that, because we can just leave you just do your own thing. And the chevron says, I'm gonna do my own thing. I'm gonna switch my origin. So our UV is from 0 to 1 right now. If we do UV minus, if we subtract half, now UV is from minus half to half squared. Yeah. And so now we've actually moved our origin from here to here for both x and y. We only needed to do it for, yeah, that just makes more sense. And then we can go further and say UV times equals 2. And this will take it, you guessed it, from -1 to 1 squared. Let's just verify this is true. So we can say color will subtract the length of UV. So this will, the length of UV, so UV is 0 in the center, and as you go out, it will, if you imagine the origin and you have UV as some vector pointing with component to whatever coordinate. So like the top right here, you have vector, you have 1x, 1y, so magnitude √2. So that length will be √2, and you'll subtract, so here you'll subtract √2, which is over 1, so it's going to be black. It'll be black, it'll be like this, and it'll be blackness, and then it'll fade out. Let's just see it. Hello. It's not working. What if we say color is equal to the length, and we do that like this? This will certainly, yeah. So why can I not subtract? Why can I not subtract? Let me subtract 1. Yeah, and that is. So why can I not subtract? I don't understand. There. It's kind of cool. You turn the, dim the lights, if you like, in some sort of like small contained area, say, and you have yet to emerge. Just hypothetically speaking, that's kind of the effect you get. And so yeah, we can see that the origin's here. Now we need to draw these. So This is like, we're going to draw 5 stripes. These I'm gonna call it ice cream because that's just like the vibe I'm getting. This ice cream, the ice cream chevrons, you want to draw the stripes and then somehow, or actually, because the Y is mirrored. So if you're drawing stripes and then you rotate everything by 45, you'll preserve these widths. The difficult way, yeah, and if this is the origin, then we can just rotate. Okay, awesome. So like that should just work. And then here, like along this, if we're here, okay, yeah, that should actually work. Awesome. Okay, so what we can do is we'll have generate gay, and then we'll say generate ice cream. So ice cream being these, and then eventually on top, finally we'll do intersects. But to generate ice cream, we'll only generate ice cream. The color will be, let's say, we're gonna mix from, we have ice cream, and then we go over to gay. So let's just say that ice cream for now. We can go 011. That's a nice, yeah, cyan. And then we'll go color. And actually, let's do, for now, let's do vec3 color. You'll color, you're gay. You're gay, just kind of objectively, like, you're the essence of gay if you're this flag. Yeah. Mix, and we'll step when uv.x is 0, because now we're at the origin. So there, it's backwards. Oh, yeah. Why do I think, what, I don't know. The uv.x, boom, boom, we got ice cream over here, gay over here. Now, and just, we converted from -1 to 1. I think for, maybe it will make more, yeah. So we'll stay from -½ to 1/2. Just so these units will then be the same. If we did 1 to 1, we'd have to have this, or double, whatever. Exactly. This is why you don't even worry about stuff like that. You don't have to do anything. We'll just be able to use this unit. So ice cream width, float ice cream width is just simply 84 over 1059. 84 over 1059. That is our ice cream width. That is the percentage of 1 being the entire width of the image that each slice will occupy. So now we just do the same thing. We do this same sort of, so yeah, let's generate, okay. So generate ice cream, and then we'll say determine final color. So it will be a mix between ice cream and gay. So now let's just get the ice cream going. So yeah, so same thing here, vec3 ice cream, let's call it ice. We're gonna mix from, oh yeah, okay, and I need to grab these colors as well. So, so now we'll just do the same thing. And this is a move origin to center. So for the ice cream, now Vec3 ice. Vec3 ice will be a mix from brown and black. And we will step at, negative IW UV.X. And then, yeah, instead of this cyan, now we'll be able to do ice. And there we go. And now we'll just kind of do this same rinse and repeats. We'll have this black stripe and the brown, and then instead of brown, it'll be brown and cyan. So Vec3 brown cyan will mix from cyan to brown, and we'll step at -2 times the ice width. UV.X compiles, instead of brown, we'll do brown cyan. Nice. And then Vec3 cyan to pink is mix pink cyan step at -3 times IW UV.X compiles. Now instead of cyan, we have cyan pink. Nice. And finally Vec3 white to pink step -4 times IW UV.X, and then instead of pink we'll do white pink. Cool. So that's the ice cream done. Now we should be able to rotate our coordinate plane 45 degrees so that these stripes will instead be drawn like that. Or wait, yeah, like that. And then we'll flip it along the Y, like we'll mirror on Y, so we'll get this. But it'll be like, yeah, but hopefully that makes sense. So now how do we rotate? Well, that can be done simply with the rotation matrix, with 2D rotation matrix, which is simply this. If you have a vector, which we do, and you rotate it by this matrix, for any given theta, it'll rotate it by that. And so we can literally just do that. Now if we do, ooh. Okay, so that should be, let's just see what happens. So let's do UV times equals, and we'll do a map 2, and we have, and let's go float A. Our angle is 3.1415 over 2 is 45 degrees. Half a pi. No, fourth of a pi. Half a pi is 90. So cosine A, neg sine A, sine A, cos A. Boom. And this is like an extremely helpful thing to know, even if you haven't really thought about matrices or linear algebra. It still just comes up all the time when you want to rotate. So cosine, neg sine, sine, cosine. Just kind of have to memorize that. There's ways to derive the formula. It's nothing super crazy, but I don't know a cute one off the top of my head, so I'm not gonna say anything. But we can see here that things are rotated. And in fact, if I go iMouse.x over iResolution.x, now we can rotate it with our mouse. And so 60.04. Now we can rotate by pi. So that's cool. Um, but what are we looking for? We're looking for, well, actually, we can't really get what we need from here. Actually, it's kind of like this is wrong. We rotate. We need to rotate in. So can we just do this? Can we just make the A negative? Ooh, why is it glitching? Yeah. So that will work. And then if we do 45, so instead of negative 40, so 3.1415965. Ugh. 3.141599265. 3.141599625 was just 5. Yeah, no, digits of pi. 141599265. 141599265. 9265. Cool. Over 4. That's pretty good. Okay, and now. If, oh god, why is it? Okay. So we have this rotated. This editor's being glitchy. I'm gonna grab everything. So I'm gonna grab Y. Okay. Yeah, shader toy. I broke it somehow, but that's fine because we're back. So leave that. Okay, so now we can just do uv.y is the absolute value of uv.y, and this will there. That will flip it, but it's wrong. It's wrong because why? Because where's Wikimedia? Wikimedia. I lost it. It's gone. This one's cool. Okay, I mean, like, that's that. Dude, you've definitely seen this before. Let's just do intersects. That should be fairly easy. So, and yeah, so this will just be an additional stripe in the ice cream, although we'll generates, intersects. We'll go, we're gonna is. Ooh, how do we do this? Because we'll want, like, this will just be another stripe. So instead of ending Y, we'll end. So maybe we could do white pink instead of white. We'll have vec3 is, which is going to be mixed from yellow to white, stepping at -5 times IW uv.x. This is a bit sloppy. And then I instead of whites, we'll do is. Okay, cool. Now, so I mean, that's like, it's just too big. Yeah, we can shrink it down by changing IW, and that already looks way better. You can comfortably fit a little intersect circle in there, and we'll do that. So, oh my god. So, and drawing circles with shaders is easy. The only thing is like we have rotated our coordinate plane. Like if we said draw a circle at negative 2x 0y, that's not going to be here. That's going to be like here because it's been rotated. So, and so we could find some magic number that'll like somehow make a circle, but that's messy. So, what is probably the best to do is we have, and this is this is messy code, honestly. I mean, this is less educational, more just you know, happy you came along the ride with me, but we can just draw a circle like on top afterwards. So, so we just need to preserve our original UV, which, and we could like create it again, but I think it'd make more sense to say if we do vec2 UV and then this is rotated, or we could say ice cream, and then all of these will be based off the ice cream UV coordinates instead. And so this will obviously compile to be the same thing. Determine file color. We still want that. Times UV. Okay, so it's wrong. What the fuck? Shut up. So let's just grab a copy. So we'll say that vec2 UV naught. UV naught is just UV at this point. So now we have a copy of our UV when it's 0, 0. And so with that, we can say, we can just do a real cheeky, like, if the length of UV is less than or equal to 0.1, then color is intersex breaking. And that, yeah, okay. So that draws a circle at 0, 0. Now we can just shift it over. So plus vec2 0x, or let's say like 0.5x 0 y. That's too much. 4, 3, 2, 1, 1, 5. Ah, UV naught. 2, 3, 4. See, okay. This is like, I'm not happy with this. There's better ways. Maybe I'll come back and redo this better one day. But this is proof of concept. You can like kind of feel these things. Give me like, okay, 3, 7, 5, 3, 9. Okay, that's not. Just do 4. Okay, So then all we need to do is carve out. So if the length UV not UV we could say the we could have a vector which is the origin intersects circle origin. Will just be UV naught plus vec2 0.40. And so now if the length of ISCO is less than 1, is purple. If it's less than 1 and if it's greater than 0.5. 0.1. And there we go. We did it. In 64 lines of shader code, which this is horrendous. Yeah, but it works and it's done. You can see it if you want it. If you want it to not, if you want it like there, now it's an actual circle. So that's pretty cool, I think. IMO, if you wanna, show your colors, but on the GPU, that's how you do it. So thank you for watching this whole thing. I kind of just woke up this morning and said, let's record a live shader art thing. So I've recorded an hour and 17 minutes of this. I'll see how long the final cut is. But yeah, thank you. Subscribe if you want to see more shader art, or just more me, I guess. But yeah, see ya.